So hi everybody and welcome back to C++ tutorials for absolute beginners. This video 303, and this video we are not going to make the examples because we have to cover one more topic first, which is reference declaration. And we know already reference declaration because we have covered it a little bit, but now we have covered the second part here, and you can see the second part with double ampersand is our R value reference declarator. The first one, L value reference declarator, here this example we already know. And the nice thing is the second one is very easy as well, just two ampersand. But important here is the wording. Now we call the first one not just reference, we will call it L value reference. This one, when you see something here, so it's a L value reference. And when I say L value reference, careful, I mean just this part here, not with the name, because the name, the whole expression is an L value, not L value. But this will be important later. For example, here in the second example, here we have a R value reference, right? But here is a name, right? The whole expression is a L value, even we have here an R value reference, and this is confusing and can cause problems, and we will see some examples there what I mean with that. But keep in mind we are distinguishing this part and this part now. Alright, and the nice thing is we talked already about L values and R values, so we now know a little bit what does this mean. So when you see L value reference, the first one which we all time use, we are referring to an object which has a storage location. So L value. And when you see R value, we are talking about temporaries, which means which is created right now. And here an example, what was a temporary again? Here, for example, here I create a variable. Here this number 5 is a PR value, for stands for pure R value, which means it is a temporary. Why is this a temporary again? Because I just created this one here, but not me, more the compiler is creating this 5. It has not a storage location, it is just created and assigned directly to the storage where my number is. And this that's why these value categories are very important now and helps us to distinguish. So when you see L value, we are referring to an object. For example, here is an example. I create here a new R value reference. I call it this my reference number, and with the L value reference here, sorry, not R value reference, L value reference here, I need a valid object, and here I created this object, and this object here has a storage location. That's why we have here an L value reference, and that's so the naming and the value categories makes now a little bit more sense. And yeah, we can combine them, this knowledge, and understand it a little bit more in depth. But let's go here a little bit more, and you can read here a little bit. I just point out this one here. References are not objects. That's very important. So when you see something like that, this is a variable name. Don't take it with this one here. This is also a variable name. The difference is this variable name is now an object because I create here an object. It has a storage location. This reference here creates also a name, but the reference itself is more or less like a pointer. We learned this pointer have not really a storage location. They are pointing to a storage location. And in for reference, we say they refer to a storage location. And you can see here, this one is referencing this storage location, which means with this reference, you can manipulate now this storage location, which I just created here. And why is this so important to understand this one? Because with this knowledge, you know you can't do something like that. You can read here a little bit more. And here are the examples which you can't do. So you have here the reference. Here is my L value reference. And here is an array. And this is not allowed. Why not? Because this array we know will decay to a pointer. This is more or less the first example will look like this one, the second example. And then we have here a reference and here a pointer. And a reference need all time is required object, right? So here, and this is not an object. A pointer is not an object. The second one is also not an object. Here we have a reference. We require an object. This one is not an object, so that will not work. All right, that's why we have here the errors. All right, that is so the introduction for this page. Important here again, the namings, we are calling them now L value reference, R value reference. And important is now careful about this one. When I say R value reference, it's just this part, not the whole part here, because the whole expression is an L value, and we will see later an example. We go here a little bit more, perhaps this one here, just to mention it. This one is a reference collapsing, and this occurs only in two special cases. You can read this one here in templates, which we have not covered yet, and in type defs. And normally this is not allowed. What we see here, what I mean with what we see here. So here, what they are doing is, when we look this, here is a type def, and type def means just change the type to a custom name. So I want, instead using the type which is given in C++, like this one here, the int end, I want call this type now lref. So in my code I have all time, instead writing int 8, I write lref. But this one here is not good. If the type is very short, then you keep the original type because it's more readable. The question is then why they do something like type def. The reason for that is sometimes you have a very long type which covers almost one line, and then you say, oh no, let's make this big line very short like this one. Then you need this type defs. But when it's short like that, don't use a type def. Use just the short int, the short type. But here, in this case, reference collapsing here, they are anyhow breaking the rule which we learned here on top. And with this type def here, how they are breaking the rules. Here, I said, is an error, right? So int end and ampersand one more, or something like that. Okay, this is not the same example, but similar. It says here, you have here this lref, this one here, which is that one, and then you add here a second ampersand, and then the whole thing becomes to an int end. What I mean here is an example. This is the same thing like there. So instead here, this lref, you would write normally here, so behind the scene, it is treated like this one is int end, but careful, this one is not allowed, and this one would be an R reference. That's why you are not allowed to write it so. And you have to use this type def here. That's why it's so special. And then it becomes a int. So this one will result to this int here. But yeah, you are replacing this more or less. And the thing, you are doing this with the other ones too. So you have here two ampersands, lref, so int end. Now the all three, you have three, are still collapsing to this one. And yeah, that goes on. You can read this lref. And the important part is here actually by on this collapsing rule, and that makes it easy. The only time when it's collapsed to int reference, R reference, is when it's already a R reference. You can see if it's already here an R reference, and you have again R reference, then it becomes R reference. In all other cases, it will be L reference. And again, you see we are using now this wording here, L reference, R reference. And for this video, I stop, but I will continue in the next video with the other ones, which we already know. That's and there are some new things actually. And yeah, If you have any questions so far, write in the comment section. See you in the next video. And like all time, have fun and never give up, and bye.